What if the most powerful telescope humanity has ever built pointed its golden eye into the deepest part of the universe and saw something it was never supposed to see, something that made scientists go quiet in a control room, something that, for a few hours, nobody wanted to talk about on the record? This is not science fiction. This is the story of the James Webb Space Telescope, a $6.2 billion machine sitting nearly 1 million miles from Earth, and the strange, unsettling, and genuinely mysterious moments where its data made even seasoned astronomers pause and ask, "Are we ready for what we might find?" Stay with me, because by the end of this video, you are going to understand not just how Webb works, but why some of its discoveries have quietly unsettled the very people who built it. We're going to walk through the disasters that almost ended this mission before it began, the impossible galaxies it found that shouldn't exist according to our own physics, the strange chemical signatures detected on a planet that sit right at the edge of what we call a biosignature, and the uncomfortable questions scientists are now whispering about instead of shouting. If you've ever looked up at the night sky and felt that itch of what if we're not alone, or what if the universe is far stranger than we've been told, this is the video for you. Make sure you watch all the way through, because near the end I'm going to share the one finding that NASA has been the most careful, almost too careful, about explaining to the public. Let's start at the beginning, because to understand why Webb's discoveries are so shocking, you need to understand just how close this entire mission came to never happening at all. The James Webb Space Telescope was not supposed to take 3 decades and balloon to over 10 times its original budget. It was not supposed to require 144 single-point failures, meaning 144 individual mechanisms that all had to work perfectly, with no second chances, no repair missions, no astronauts floating up to fix a stuck panel the way they did with Hubble. Webb was launched on Christmas Day 2021, folded up like a piece of origami inside a rocket, and over the following month it had to unfold itself, completely autonomously, nearly 1 million miles from Earth, roughly 4 times farther away than the Moon. If a single hinge failed, if a single sunshield layer tore, if a single mirror segment didn't lock into place, the mission was dead, not damaged, not repairable, dead forever, floating silently in the dark. Engineers called this period the Weeks of Terror. Here's the part most people don't know. There were moments during that deployment where telemetry data coming back from the spacecraft didn't perfectly match what engineers expected. For a brief, tense window, controllers genuinely weren't certain if a critical sunshield membrane had torn during deployment. If that shield had failed, heat from the sun would have cooked Webb's infrared instruments, turning a $6 billion telescope into an extraordinarily expensive piece of space debris. Nobody was going to fly out there and fix it. There was no plan B. It worked. Against the odds, every single one of those 144 failure points succeeded, one after another, like a perfectly executed magic trick performed in total darkness with no audience and no second take. But that fragile, almost impossible success is part of the reason everything Webb has discovered since carries this strange weight. This telescope shouldn't have worked, and yet it did, and what it immediately started finding broke a lot of what we thought we understood. Before we go further into the discoveries themselves, I want you to understand exactly why this telescope is fundamentally different from anything that came before it, because this context matters enormously for everything we are about to cover. Webb operates primarily in the infrared spectrum, unlike Hubble, which mostly observes visible and ultraviolet light. This is a deliberate engineering choice, and it's the key to everything Webb does. As light travels across the vastness of the universe, the expansion of space itself stretches that light's wavelength, a phenomenon called redshift. The light from the earliest galaxies in the universe, formed not long after the Big Bang, has been stretched so dramatically over billions of years of travel that it has shifted entirely out of the visible spectrum and into the infrared. This means that to see the very first galaxies that ever formed, you need an infrared telescope. Hubble simply cannot do this. It's not built for it. Webb can, and that single design decision is the reason this telescope has rewritten so much of what we thought we knew in such a short period of time. This is also why Webb had to be cooled to an almost unbelievable degree. Infrared light is essentially heat radiation. If Webb's own instruments were warm, they would essentially be blinded by their own heat signature, drowning out the faint infrared light from billions of years ago that they're trying to detect. This is why Webb operates at around -233 degrees Celsius, only a few dozen degrees above absolute zero, the theoretical coldest possible temperature in the universe. The 5-layer sunshield, each layer roughly the size of a tennis court, is engineered to block heat from the Sun, Earth, and Moon so precisely that the side of the telescope facing the Sun can reach over 85 degrees Celsius, while the instrument side, just meters away, stays colder than almost anywhere naturally occurring in our solar system. That temperature differential, maintained across a few meters of folded material in the vacuum of space, is one of the most remarkable engineering achievements in human history, and it's the silent, unglamorous reason Webb can see what it sees. Now let's talk about the first true gut punch this telescope delivered to the scientific community: galaxies that are too old, too big, and too mature to exist. When Webb released its first deep field images in July 2022, astronomers expected to see faint, young, blobby galaxies from the early universe, messy little smudges of light representing galaxies still in their infancy, maybe a few 100 million years after the Big Bang. Instead, Webb found fully formed, massive, almost disc-shaped galaxies that looked far too mature for how early they appeared in cosmic history. These came to be informally nicknamed universe breakers. Some of these galaxies appeared to have grown far too massive, far too quickly, accumulating stars at a rate that, according to our standard model of cosmology, simply should not be possible in the amount of time available since the Big Bang. Now, to be clear and scientifically honest with you, this doesn't mean the Big Bang is wrong, and it doesn't mean physics is broken. What it does mean is that something about our models of early galaxy formation is incomplete. Maybe star formation happened faster than we assumed. Maybe dark matter clumped differently in the early universe than our simulations predicted. Maybe there's a piece of physics we're simply missing. But here's the unsettling part. For an entire field of science that prides itself on precision, finding objects that shouldn't exist yet, based on the bedrock of an accepted cosmological model, is the equivalent of an engineer finding a bridge standing upright that by every calculation should have collapsed under its own weight. It works. It's standing there, but the math says it can't be. This is the first crack. The first sign that Webb wasn't just going to confirm what we already believed about the universe. It was going to challenge it, repeatedly, discovery after discovery. Let's sit with the implications of this for a moment, because it's bigger than most people realize. Our entire understanding of cosmic history is built on a model called lambda-CDM, a framework describing how the universe expanded, how dark matter clumped together, and how the first stars and galaxies formed out of that primordial structure. This model has been remarkably successful for decades. It explains the cosmic microwave background radiation, the large-scale structure of the universe, and the rate of cosmic expansion with extraordinary precision. So when a brand new instrument starts finding objects that don't fit neatly into that model within the very first year of operation, it sends a ripple of genuine unease through the field. Not panic, not everything we know is wrong, but a real, professional unease, the kind that fills conference halls with murmured conversations and fills academic journals with cautiously worded papers using phrases like intention with and warrants further investigation. Now let's go somewhere even stranger, a planet called K2-18b. In September 2023, Webb detected something in the atmosphere of this distant exoplanet, a world over 100 light-years away, orbiting a red dwarf star in the habitable zone that made headlines around the world. Webb's instruments picked up signs of dimethyl sulfide, a molecule that, on Earth, is produced almost exclusively by biological life, specifically marine phytoplankton. Let that sink in. A chemical compound that, as far as we know, is a byproduct of living organisms, detected in the atmosphere of a planet outside our solar system. Now, I need to be the responsible voice here for a second, because there's a difference between exciting and irresponsible. The detection was not definitive. The statistical confidence was not at the level scientists require before making bold claims. There's an important distinction in science between detected and confirmed beyond doubt. Multiple research teams have pushed back, suggesting alternative non-biological explanations for the signal, or arguing the data simply isn't strong enough yet to draw conclusions either way. NASA and the lead researchers were notably, almost painfully cautious in how they announced this. They used careful, hedge-filled language. They emphasized potential and consistent with rather than evidence of. Why so cautious? Because the implications of being wrong about something like this, announcing a possible sign of alien life and then walking it back, would be catastrophic for public trust in science. But here's the question that keeps astrobiologists up at night. If this signature is even partially real, even if it's not biological in origin, why are we suddenly seeing these, almost biosignatures, pop up the moment we point a strong enough telescope at the right kind of planet? Is it because such signatures are rare and we got lucky? Or is it because they might be more common across the galaxy than we ever expected, and we simply never had the technology to detect them before? Let's also talk about what K2-18b itself is believed to look like, because the planet itself is fascinating independent of the chemistry debate. It's classified as a Hycean world, a theoretical category of planet with a hydrogen-rich atmosphere sitting above a vast, possibly planet-wide ocean. If this classification holds up, K2-18b wouldn't look anything like Earth. It would be a world entirely covered in water, with no continents, no land at all, just an endless dark ocean beneath a thick, hazy atmosphere, orbiting a dim red star that bathes the entire surface in a perpetual reddish twilight. The pressure at the bottom of an ocean that deep would likely be crushing, possibly compressing water into exotic forms of high-pressure ice that don't naturally exist on Earth. It's an alien world in the truest sense, and the fact that we can analyze its atmospheric chemistry from over 100 light-years away, using a telescope that wasn't even operational 3 years ago, is a genuinely staggering achievement, separate from whatever the biosignature debate ultimately concludes. I want you to pause and really think about scale here, because it changes everything about how you should interpret discoveries like this. Our Milky Way galaxy alone contains over 100 billion stars. Current estimates suggest there could be tens of billions of potentially habitable, Earth-sized planets in our galaxy alone. And our galaxy is just one of an estimated 2 trillion galaxies in the observable universe. When you zoom out to that scale, the question stops being, are we alone? And starts becoming, given those numbers, how could we possibly be alone? Webb isn't designed to definitively answer that question. But every single discovery it makes is another data point pushing the scientific community closer to taking the search for biosignatures seriously, not as fringe science, but as a legitimate, funded, high-priority field with entire research divisions now dedicated to it. Now here's where things get genuinely eerie, because once Webb proved it could look back in time over 13 billion years, scientists started using it to study not just the early universe, but specific anomalies that had puzzled astronomers for decades. Let's talk about Webb's observations of supermassive black holes, because what it found here is arguably one of the most disturbing discoveries of the entire mission. Supermassive black holes, the kind found at the centers of galaxies including our own Milky Way, were thought to form gradually through the slow merging of smaller black holes and the steady accumulation of matter over billions of years. But Webb has detected supermassive black holes that existed shockingly early in cosmic history, too early, too massive, too fast. Some of these black holes appear to have grown to masses millions of times that of our Sun within just a few 100 million years after the Big Bang. To put that in perspective, that's like finding a fully grown adult human within days of conception. It defies the growth timeline we believed was physically possible. Some researchers have proposed a wild but increasingly serious idea that some of these black holes didn't form through the slow death and collapse of giant stars, but instead formed directly, massive clouds of primordial gas collapsing straight into black holes without ever becoming stars at all. This is sometimes referred to as the direct collapse theory, and if it's correct, it means the early universe was an environment so violent, so different from anything we observe today, that the normal rules of stellar evolution simply didn't apply yet. We are, in a very real sense, still trying to understand the early childhood of our universe, and Webb keeps showing us baby pictures that don't match the family story we've been telling for decades. There's another wrinkle to this black hole mystery worth exploring, because it connects directly back to those two mature galaxies we discussed earlier. Some of Webb's most puzzling early universe objects appear to be what researchers have started calling little red dots, small, extremely compact, intensely red objects found in huge numbers in the deep field images. For a while, nobody was entirely sure what these were. Were they extremely dense, dusty young galaxies? Were they the early growth phase of supermassive black holes, glowing not from starlight, but from superheated materials spiraling into a black hole's accretion disk? The emerging consensus increasingly leans toward the second explanation, that many of these little red dots represent an entirely new, previously unknown phase of black hole growth that existed only in the universe's youngest years and has never been observed before Webb came along. An entire previously invisible chapter of cosmic history, hiding in plain sight, waiting for an instrument sensitive enough to finally read it. Now let's talk about something else that rattled the scientific community: the UMBOs. In 2023, Webb detected dozens of free-floating, planet-sized objects in the Orion Nebula that are not orbiting any star at all. They were nicknamed Jupiter Mass Binary Objects, or JUMBOs. These are pairs of objects, roughly the mass of Jupiter, gravitationally bound to each other, drifting alone through space, untethered from any solar system. According to most existing models of planet and star formation, these objects shouldn't exist in the numbers Webb found them in. They're too small to have formed the way stars form, through gravitational collapse of massive gas clouds, but planets aren't supposed to form in pairs, untethered, floating freely through interstellar space either. Their existence challenges fundamental assumptions about the dividing line between what we call a planet and what we call a star, categories we've used confidently for over a century, suddenly looking a lot blurrier than we thought. I want you to sit with that for a second, because this is the recurring theme across almost every major Webb discovery. It's not that the telescope found something supernatural or impossible in a sci-fi sense. It's that it found real, physical objects that simply don't fit into the categories and timelines we built our entire understanding of the universe around. Every single "this shouldn't exist" headline you've seen about Webb traces back to this same root cause. We are, for the first time in history, seeing the universe with clear enough eyes that our old assumptions are starting to visibly crack. Let's also talk about the strange flickering objects observed in some of Webb's deep field surveys, something that didn't get the same headline treatment as the alien ocean world story, but which some astronomers consider privately to be just as unsettling. Webb has observed certain extremely distant, extremely compact objects that emit light in patterns inconsistent with known stellar processes. Some of these objects flicker, brighten, and dim in ways that don't match any cataloged type of star, supernova, or known transient event. Now, before you let your imagination run wild, astronomers are not seriously entertaining alien megastructure as the leading explanation here. The leading hypotheses involve exotic stellar phenomena we don't yet fully understand: unusual binary star interactions, previously uncharacterized classes of variable stars, or measurement artifacts from instruments still being calibrated for entirely new kinds of observations no telescope has ever made before. But the honest scientific answer, the one researchers will give you off the record over coffee rather than in a press release, is we don't fully know yet. And we don't fully know yet, coming from the team operating the most sophisticated telescope ever built, is a genuinely unsettling sentence. This is the uncomfortable truth about Webb that nobody wants to put in a flashy headline. The telescope is so far ahead of our current theoretical models that it is generating data faster than science can confidently explain it. We built something that can see further and clearer than our own theories can keep up with. That gap between what we can observe and what we can explain is where all of these disaster headlines and shocking truth rumors come from. It's not that Webb saw a UFO. It's that Webb is routinely seeing things that don't fit cleanly into the boxes we've spent a century building, and every astronomer involved knows that admitting confusion publicly risks being misrepresented by sensationalist media, which, ironically, happens constantly anyway. Now let's address the elephant in the room, because I promised you I'd talk about it. The question of whether Webb has detected anything resembling extraterrestrial intelligence, and why that question makes scientists so visibly uncomfortable. The honest answer is no, Webb has not detected any confirmed signal, signature, or structure attributable to intelligent extraterrestrial life. It is not designed to search for radio signals like the SETI Institute's array of radio telescopes. It is not designed to detect technosignatures in the way some proposed future missions are. What Webb is designed to do, and does extraordinarily well, is analyze the chemical composition of distant planetary atmospheres, study the formation of galaxies and stars, and observe deep time. The biosignature detections, like the dimethyl sulfide signal on K218b, are about potential signs of basic biological activity. Think microbial life, ocean ecosystems, possibly nothing more complex than what existed on Earth for the first 3 billion years of its history, not little green men. But here's why the public conversation gets so distorted, and why James Webb disaster videos and clickbait headlines spread so fast. Every single ambiguous, unconfirmed, statistically uncertain finding from Webb gets stripped of its nuance the second it hits social media. A cautious scientific paper that says this chemical signature is consistent with, but not conclusive evidence of, biological activity pending further observation becomes, within 48 hours online, NASA confirms alien life. That's not Webb's fault. That's not even really the scientists' fault. Most of them are doing exactly what good science requires, being conservative, careful, and honest about uncertainty. It's a structural problem with how complex scientific findings travel through a media ecosystem that rewards shock over accuracy. And that brings us to the real disaster this video's title is hinting at, and I think it's more interesting and more true than any alien conspiracy theory could ever be. The real disaster isn't that Webb saw something it wasn't supposed to see. The real disaster is what happens to scientific trust when extraordinary, nuanced, genuinely fascinating discoveries get flattened into either boring jargon nobody watches, or wild misinformation that erodes public trust in the very institutions doing this incredible work. Every time a Webb confirms aliens video gets debunked a week later, it doesn't just embarrass the channel that posted it, it makes the next legitimate, exciting, genuinely significant discovery a little harder for the public to take seriously. That's the actual disaster scenario playing out in slow motion, and it's one we should all care about. Let's widen the lens again and look at some of Webb's other achievements, because the real story is wild enough without exaggeration, and I want you to walk away from this video genuinely informed, not just entertained. Webb has now observed light from a galaxy designated JADS GSZ140, confirmed to be one of the most distant galaxies ever detected, with light that traveled roughly 13.4 billion years to reach us. When you look at that light through Webb's mirror, you are not looking at how that galaxy looks today. That galaxy might not even exist anymore in its observed form. You're looking at a photograph of the universe when it was less than 300 million years old, roughly 2% of its current age. Think about that. You're seeing baby pictures of the cosmos itself, captured by a machine sitting nearly 1 million miles away, cooled to near absolute zero, unfolded by itself in the vacuum of space with zero margin for human error. Webb has photographed the pillars of creation in stunning new infrared detail, revealing thousands of young stars hidden inside dense columns of gas and dust that were previously invisible to Hubble's optical instruments. These pillars, located in the Orion Nebula roughly 7,000 light-years away, are themselves slowly being eroded by radiation from nearby young, hot stars, meaning the very structures we're looking at are, very gradually, on a timescale of hundreds of thousands of years, dissolving away. We are watching something genuinely temporary on a cosmic scale, frozen in a single, extraordinary photograph. Webb has studied the atmosphere of Jupiter's moon Europa, finding carbon dioxide on its icy surface in regions that, according to other data, may be connected to a vast subsurface ocean believed to contain more liquid water than every ocean on Earth combined. This matters enormously for the search for life within our own solar system, because it suggests that the chemistry happening on the icy surface might be connected to chemistry happening in the ocean far below, meaning Europa's hidden ocean might not be chemically isolated from the surface at all. That's a significant clue for any future mission hopping to search that ocean for signs of biology. Webb has also directly imaged exoplanets, actually captured photographs of worlds orbiting other stars, something that was nearly impossible before this telescope existed, because the light from a host star is typically billions of times brighter than the planet orbiting it, like trying to photograph a firefly sitting directly next to a lighthouse. Using a technique called coronography, Webb essentially creates an artificial eclipse, blocking out the overwhelming glare of the host star so the much fainter light of the orbiting planet can be captured directly. Some of these direct images have revealed planets far larger than Jupiter, still glowing with residual heat from their own formation, slowly cooling as they age, giant worlds that formed in environments completely unlike anything in our own solar system. This is what makes Webb genuinely one of the greatest scientific achievements of human history, without needing a single exaggerated claim to back it up. We built a machine that lets us see backward through 96% of the universe's entire existence. We built something that can analyze the chemical fingerprint of an atmosphere on a planet so far away that its light left before complex life even existed on Earth. And we did it with a margin for error so thin that 144 individual mechanical failures had to not happen in a sequence 1,000,000 miles from any human hand that could fix it. So let's return to the central question this video opened with. What if Webb sees something it wasn't supposed to see? I think, having walked through everything we just covered, the honest answer is this: it already has, repeatedly, and it's going to keep happening, because that is precisely the point of building an instrument this powerful. Every great leap forward in observational astronomy has broken something we thought we understood. Galileo's telescope shattered the idea that Earth was the center of the universe. Hubble's deep field images shattered our sense of how many galaxies actually exist. And now Webb is shattering our timeline for how quickly galaxies, black holes, and possibly even the chemical building blocks of life can form. This isn't a disaster. This is exactly what scientific progress is supposed to look like: uncomfortable, humbling, and endlessly fascinating. The scientists who built Webb didn't build it to confirm what we already knew. They built it specifically to find the things that would force us to rewrite the textbooks. And it's doing exactly that, on a timeline faster than anyone expected, with implications that are still being unpacked in research papers being published as you watch this video right now. Somewhere right now, there is a team of astronomers staring at a new dataset, refreshing their screen, looking at a number that doesn't match their model, and feeling that exact same electric mixture of confusion and excitement that has driven every major scientific breakthrough in human history. Before you go, I want you to actually sit with the scale of what we talked about today. 1 trillion galaxies, tens of billions of potentially habitable worlds in our galaxy alone. A telescope capable of looking back across 96% of all of cosmic time. Chemical signatures hinting, not confirming, but hinting at the possibility of life beyond Earth. Black holes that grew impossibly fast. Galaxies that look too old to exist. Free-floating planetary pairs drifting through the dark with no star to call home. We are living through the exact moment in human history when the tools to finally answer some of our oldest questions have just become powerful enough to start delivering real answers. Not certainty yet, but real, tangible, data-backed answers arriving faster than at any other point in the history of astronomy. If this video genuinely made you see the James Webb Space Telescope differently, do me a favor and hit that subscribe button, because we cover stories exactly like this one regularly: real science, explained honestly, without the clickbait exaggeration that so much of this topic gets buried under elsewhere. Drop a like if you made it this far. It genuinely helps this channel keep making deep, long-form content like this instead of chasing cheap, shallow clickbait. And leave a comment letting me know, out of everything we covered today, which discovery shocked you the most: the impossibly early galaxies, the black holes that grew too fast, the possible biosignature on K2-18b, or the free-floating Dew MBOs drifting alone through Orion. I read every single comment, and I want to know what you think the next big Webb discovery is going to be. And here's my real question for you, the one I want you to actually think about before you close this video. If Webb, or a future telescope even more powerful than it, eventually did find conclusive, undeniable evidence of life on another world, Are you ready for what that would actually mean for how we see ourselves? Let me know in the comments. I'll see you in the next one.